Okay, we're back on the PPI here. Got a new pot in. That'll go down here. You guys can't see that. The board's so big. So put a new one in. It's not the smooth shaft style. This one's knurled, but from the outside when the cover plate's on it, still all you can see is a screwdriver shaft. So we're going to carefully turn this over. See about getting this soldered in so we can test the one channel that did not appear to be blown. Hold that sucker up in place. Make sure she's in the right spot. Get this other corner. You guys can see my poor bald head. I need to trim it and shave it and look respectable instead of like a scruff. It's just been so busy. Ain't had much time. I'm going ahead and fill those little vias with solder on the back side there. This last one soldered in. All right. Technically, now that we have the bias jumpered out, power supply rebuilt, this one channel over here we should be able to do. The only reason why we couldn't test it before is because we was waiting on this little pot. So while waiting on that, I also picked up this had an Orion plug on it. I'm going to keep the Orion plug because it's not the correct one, and it does not have the correct knob on it. And I went ahead and ordered a PPI one with the actually larger slots to take the bigger wire, and it's got the correct notch in it that fits in here so that this can only go one way, so that it's keyed. And so this is the correct plug. It even has PPI on it, so it's like factory, except the notches have been milled slightly to accept a little bit larger wire, which this amp kind of needed. And so we're going to work on hooking this up. So it should be positive over here. And this worked out real well because I've actually got Orion amps that need this plug. So it was a good swap. It'll make Andy happy. Or Andy's buddy. I think this is his buddy's amp actually. So we're going to go ahead and get this tightened up here. So now when we get into this drive and output section, and boy, that's brand new and it's tight. And without an amp body to push against, it's kind of a pain. Yeah, I'm worried I'm gonna break something. Trying to shiv it on there without having a amp to physically hold on to. I'm pushing against stuff that's all here, so I don't like that. So I'm just going to use some clips for temporary, just to try powering it up, which is what I think we powered up the power supply with before. down here at the end. One of these, the one in the middle, is supposed to be the remote. Hook that to my remote wire. There we go. And we'll turn on the power up here. We'll get my RCAs ready. Down here at the end. Make sure we are, that's gain, it should be spun all the way to there. And then if that goes there, then that should be set mid. Alright, so we're going to try powering it up first. And we get a green light. And we're not pulling too much amps, about 1.2. So that's good. Make sure these connectors don't slide off. Grab my speaker. I'm going to go ahead and turn on the radio. We're just looking to see if that side plays over there. And that's going to give us a reference for this side. Now, these amps do have the driver cards that are very fragile. You have to be careful when you're handling these amps. I don't know if I mentioned that. If you break one, there are aftermarket replacements. They were developed by the Amp Doctor over in the UK. And there's a couple guys. Jimmy is selling them on sells them on eBay, and I also have the files so that I could recreate them over here in the US once the inventory runs out. That have been shipped over from the UK. The Amp Doctor's kind of tired of messing with making them and then shipping them and dealing with all that stuff and everything. So we worked out a deal with my PIM cards and his cards that if ever comes the need, I can produce some of them over here. So we're just going to turn it on. Oh. And we are playing. Sounds a bit distorted. So we'll have to see what that's all about. But it does play. So what I can do is I can now send a 60 hertz signal. I'll turn this off so I can move it around, not have to worry about it. Through here, and a 1 kilohertz and all that stuff, and we can trace it through. And I have not cleaned, we just put the one new gain knob in, but I have not cleaned these or any of these switches, so they probably need it really bad, and that may be a big source of it. And part of it could be with the bias not adjusted, but we didn't want to get these hot. Make sure nothing else was warm. That's all good, because we wanted to make sure we at least had some functionality. Now we can move forward with that. So I am going to set up and get my oscilloscope running and let it warm up and all that good stuff, and we will we'll come back to also trying to put a transistor in each side of this to test this other channel once I've cleaned these and stuff. So went to go clean these and stuff, and I just pulled my scope out and probed my RCA ends and found out my RCAs, my test bench ones, had started getting real intermittent and had a bad connection in them. Replaced the RCAs. You notice they're no longer the black ones. I threw those away. I've got some actual higher end, and this is the pair I'd actually meant to put on my test bench, but all the scratchy went away. Those bad RCAs. They were just cheapos that I'd thrown up here originally, and like I said, I'd got these good ones, and I'd meant to put them on my test bench, but I've just been too lazy to do it. Now it was about to bite me in the butt. But here we go. Now we got full sound coming from that channel. That channel is all good. So I'm gonna find my my transistors, and we'll work on this other side. So we got the new transistors in, the TIP 35s and the 36s, and I got them bent there, and you can see, and then I've adjusted them so that they should hold the transistor flat. We'll do the gate ones first to get them level. Burn my finger. Grabbed a hold of the metal, not the FET or the transistor. It's got me all flustered. I just want to make sure that we're smooth to the thing, because these are, oh no, they're actually right lower. They're on the edge lower, so I need to go a little lower. I'd have to adjust. There we go. These adjusted a little bit so that they end up being right and they lay flat. So we want the backs to go flat against the heatsink for maximum thermal efficiency. So what you can do is, or what I do, is I solder in the gate. Let's see, it's not the gate, it's going to be the base, the base leg first, because it's the easiest to solder. The pad will be need less heat. It's going to come through a little more. Ooh, there we go. Want that solder set up, and that'll hold it in place, so you can go back and do the other legs. That looks pretty good. Like I said, when they're properly in place, we want them to set just right. Now it's easy to tweak them and get them real close. Now I can solder them in. And sorry, I won't be saying much holding my breath. I don't have my fan on right now because I'm recording. Try to get all these in. There's not very many transistors to do. Get these all soldered in. We can test this other channel. Then it'll be about remounting it in the heatsink and redoing the bias. I'll have to make some aluminum angle iron pieces for this to help clamp it in, since you can't set the bias. Now I can go back and touch up the bases if they need it, just to make sure they're right, because I just tacked them in, some of them. There we go. That should have it in. Now we still have our jumpers in place. This and this, I believe I tracked down. These should be the bias. And I think those are DC offset. That's what I was told. I don't have the schematic for this amp. And I'm not a PPI expert. So we'll get this stuff hooked up. This should be remote here in the middle. And I'll do this way. Now we got power and ground, and I always have to look. Let me get the end cap. Positives in towards these caps. Okay, so we can turn power on. And look, and I think we got a regulated supply there, don't we? Is that what that is? Is it coming up regulated? Because that looks a little weird. It's not pulling excessive current. But is that a... Yeah, that's an SG, so got like a soft start, stuff like that. Where is our light? Our light is green, so that must be regulated. My brain is. I'd have to go back and look at the video when we fixed the power supply to watch what it was doing. So we're going to make sure we're not getting hot anywhere. Well, I've got that. So we had set the gain, we had played, oh, my speaker wire just broke. Give me a second to fix this. Oh, sweet, my wire strippers are right there. We'll get a temporary fix here. I'll just get a piece out and crimp it on there here in a minute. So we had played, there we go, I can turn that up a little. We'd played on this side over here. Let's listen. Hey, look at there. warm, let off the power. Sounds like we have clean audio. We need to get it, of course, in the heatsink before we can adjust the bias. When I come back, I'll have this in the heatsink, hopefully. I'm going to clean up the heatsink a little. And we'll get the aluminum angle clamps on to hold these down so the bias can be set correctly. We'll dial the biases back, remove the jumpers, and then set them up correctly. Actually, we shouldn't have to do anything on this side because we didn't change anything. So what I'll probably do is once it's clamped down, I'll remove the jumpers, and then I'll have this one turned back for the new side, but I won't have touched this one, and then we can crank it back to see how many milliamps up on the power supply up there. Oh, sorry, it's over here. The bias was set at once it stabilizes and everything, and then we can match this side to it. So, all right, see you in a little bit. I'll get this back in the heatsink. So you need to remember on these PPI amps, they have thermal sensors. On this one, it happens to be on the bottom of the board. A lot of the times it'll be right there on the edge of the board, equal with these, and you will need to thermal compound those so that they can accurately pick up the temperature of the heatsink. So just a good little daub on the top of them so that they get the alright. So when you start making some clamp hold downs for this amp, I've got her back in the heatsink ready to go, and I'm using aluminum angle, and the angle just gives it a little bit more rigidity. It's got a little burr on it. I will clean all that up here in a minute, but so you cut you a piece long enough to go all the way across here. You can line up with your screw. You're going to end up needing shorter of this screw. I'll mention what it is here in a little bit because I'll measure it when I go to find some. But see how this hole now, it's going to cover all the way down to this hole, and we're all good. So to transfer all those holes, you need the bottom piece, and all you got to do is stick it in there, line up the hole that you made with your first one, and get your marker, and transfer them over, and that'll get you close enough for government work. And you can always make your hole a little oversized because you can always use a washer on the hole downs. Now I'll just go drill those holes out. We will get the proper size screws. I'll tell you what that is in a minute. And we'll be able to clamp this down. Okay, so we're going to turn on the power. We don't have any signal in. It's just sitting here. And we're going to turn on the amp. And I've got a green indicator all the way over here. I'm not going to slide the amp around. And I have removed the jumper right here for this side. So it should be at its bias current. And so we're just going to let the amp stabilize. When you do it the current method, you just let the amp stabilize. The screws that go in here, 632. so I had to find some 632s. I'm using angle iron. You could use aluminum square tubing. The big kicker to realize is that the little driver transistors here in the middle, the big ones are here, and they're the ones that you want to get clamped perfectly across. Those are the ones that generate the most heat. We're not going to drive this hard enough for the power supply to be done, and that would be a little more. If you was to needing to drive this hard while testing stuff, then you need to get you some sill pad and put it underneath these, underneath whatever clamp you use, here where these are, and down by the rectifiers all the way down to the power supply, because they're slightly smaller than the big TO transistors, TO 247s, and those are the ones we're worried about clamping the outputs here. So, and if you look up here, point to my, I'm watching my screen so I can point to it. You'll see that we've started to stabilize. We're at about 1.7303 to 1.704. So we're going to take a screwdriver, and we're going to turn this bias down. We're at 1. Well, we'll let it stabilize a bit more. If it decides to be at 1.70, we just want to turn it down and see where it goes down to, and then we can subtract those two numbers and know how much to crank this one up. And so we're going to call it 1.701. So let's just go ahead and write that down. Oh, we're at 1.7, real nice. 1.700. Let's just wait a minute more. Yeah, it looks like it's stabilizing out here. We might just let that run for a little bit. So let's cross that out over here. I'm over on my notepad over here. So we'll go 1.698. So let's go ahead and turn this quickly. And it drops down to 1.574. So let's crank that back up. 1.698 was our goal. Right. Go down just a little. That's pretty good. I'll leave it right there. So I'll do some math over here. We got 2, 2, 1. So it comes up to about 122 milliamps. That's a lot. Normally I bias stuff at 50 milliamps. So we're going to turn this one actually down just a skosh. We're going to go for just a little less. And then we're going to shut the amp off. Now I've turned this one counterclockwise all the way. Now we can remove the jumper. Fire the amp back up. And now we're going to let it stabilize, and we're going to add about 110. I turned this one down just a skosh. Not a big fan of having that high of a current. Its specification may be for that high. Having a touch less ain't going to hurt. All the crunch is my pupper dog eating. I am going to go ahead and measure across the two terminals. $14 millivolt, and we got 15 millivolt of DC, and I'm not going to screw with that. That's such a low amount that I don't want to screw with those two other settings. So I think now that we've got the current, it's already jumped up there a little bit. We were at 170 and we're at 1.8. It's like it's already set. Once we took that jumper off and activated the bias circuit, it came up. So we're going to go to 193. You see how touchy that is. That's actually okay. It probably matches the other side a little bit better. About 1935-ish. I call that good. I like it. So now we just want to feel if we got any heat. I don't think we do. So I think we can turn the radio on. So this thing idles at some pretty high current, but not too bad. And let's see if we can hear the music over my dog crunching on her dog food. Can you hear that? That crunch, crunch, crunch? She's just eating away. There's one channel. There's the other channel. Pretty awesome. We shut her down. Now I'm ready to remove my clamp setup and put the factory one back in. Now the factory one's really dusty. I'm going to clean it. And then on these amps, you need to go in and you need to inspect these fingers and make sure, pardon me, I've got the hiccups there a little bit, that they're not bent out of proportion, that they're going to press firmly against all of the FETs and hold them down. So always inspect all the fingers on this style of heatsink and we'll be good. So I'm going to clean that up. And this amp's done. I'll get that back on, and then I'll actually put it to the big load, and we'll crank it hard and see as long as it endures, it'll be a done amp. So had to in recap. That's the word. I'm getting tired tonight or something. We had one blown transistor on this side, so I went ahead and completely rebuilt this by putting all new match sets and reset the bias on this side. That one blown transistor, if I can unplug some of this stuff and move it down, caused apparently the power supply to blow. And when it did, remember somebody else goofed with the drive transistors and stuff, and so had completely blown the power supply. It was all nasty up right in here and stuff. And so we removed all that, rebuilt the drive circuit, and we explained all that in, I think, part 3. Put in all new 3205s and new gate resistors and stuff, and made all that nice, and working. Got power, tested this side, it tested pretty good. Don't forget we had the jumpers to jump out the bias while we had the heatsink. Replaced these up, also fixed the gain pot. Now it's fully functional. I've checked it all over and actually replaced this. They had an Orion one plugged in, which does not have the safety key keying built into it, which, whether you really need to have that or not. The speaker plug was original. It said PPI on it over here, and so I swapped out the Orion one for one of these that actually says PPI on it. So this thing will be spot on. And so I hope you guys enjoyed it. I enjoyed doing this. I've only done 1 or 2 other PPIs ever, and so I'm learning about them. getting a little better. These are hybrid design cards in here, and if they get blown, there are replacements that are modern that you can get. They're sold by Jimmy on eBay right now. But the amp doctor design over in the UK designed them, and so those are available. And then it's just a Class AB big O amp, really nice. So I hope you learned something. I hope you enjoyed it, something like that. I really appreciate you guys. Thanks for watching a goober work on some stuff that he enjoys having fun doing. So thanks and good night.